Let me check once. Just.
Good afternoon. So welcome you all for the discussion on this year's monsoon. This is the 8th year we're doing this. For those of you new here, there's a little bit of background. We started this in 2015. And the idea was that pre-monsoon time, anyway, all the faculty usually gathered at the tea club there at that time to discuss it. And we thought it should be a little more open. And I wanted students to be involved in it. And the idea was every week something new is happening, we discuss that, but at the same time discuss your own research or some interesting paper or anything interesting in climate change, climate science related topics. Okay, very open and it is very informal. This is not a seminar. Okay? This is not a regular research seminar. We can be informal. We can make statements which will not be made in a formal seminar, right? So the idea is it's informal discussion about current research that you're doing or you're seeing some papers. I'll do an example. And it's not very long. We don't want to be, today it's a very long in the first day. Otherwise, I wanted to be 30 to 45 minutes, that's all. More than that, all of us lose interest, okay? Let me just give a few examples of the kind of thing one should be discussing, because this field is exploding and none of us can keep in touch with the research going on. Every day I find 10 papers which I should be reading, I can't read. So the idea is, we as a community, one of you read it and will tell us briefly what the paper is saying. So this is a way also enhance our knowledge. So one example, just today I saw the interesting paper which will interest Vinay, which is the global decline in ocean memory in the 21st century due to global warming. Okay? Very interesting point of view that due to global warming, the sea depth is becoming shallow, and that will cause problems for forecasting. Now, I want one of you to read the paper and tell us what is the details in that. What they are discussing is a simple stochastic model for ocean temperature, where this memory is related to the decay time scale. Okay. This time scale is what is memory of the ocean, and that's very important for a coupled model. All the whatever ability we have to predict in the long term is there in the ocean memory. It's not there in the atmosphere. Atmosphere has a very short memory. So this, if it changes, then it will affect your coupled model forecasting. So it's a very interesting paper. I just saw it today. It came out on 6th May. So one of you can look at it and tell us what it means. The other interesting paper I got today was the new idea, which is called, which is already being done in IITM. It's called scale-aware conversion scheme. That is, depending upon what scale you are resolving, you get appropriate scheme. And this is over Korea, and this is of course the highest scale, right, over Korea, and then little coarser and coarser. And they're comparing the different schemes here, green, blue, and red, with observation. This observation is IMAX, that is the satellite data. The real news is that it's not good. Okay, even using a 4 kilometer resolution at the innermost, this one, the high rain polygon which occurred, they are not able to correctly reproduce neither the amplitude nor the phase. Okay. So this is one thing of great interest to all of us. So again, somebody can look at it and tell us what they will learn. Okay, let me go on to the monsoon. Now, we have been discussing monsoon for the last 8 years. So what I want to tell you is that we started in 2015. And that was the El Nino year. Okay. And it was the first year the India Met Department forecast a drought, which is a record, because it did not do that before. Because usually all forecasting agencies want to be conservative. Okay? Because droughts are rare, they don't occur every year. So even in the popular drought, they will say 89, not 90% below, but 91%. But this year, 2015, because they have used both a statistical model and a dynamical model, they are confident and they said El Nino will cause drought. But look at the first 2 months. Rainfall, even the third month, First one rainfall was close to normal. Okay. And it so happened the rival SkyMet private forecasting agency, which does not have much of a strength, they felt it would be normal. Okay. So by mid-August, it looked as though SkyMet would be right, IMD would be wrong, and you won't believe it. The kind of media attention we have today with Twitter and so on, there some people are saying, why are you funding India Met Department with thousands of people when a private agency with 10 people can make a better forecast? So this is the pressure the ministry was at that time, I remember it. Then the thing changed. This is what happened in September. At the end, it was below normal. Okay. So that was interesting that they made a bold prediction, they were right. So they got very confident. Next year was a La Nina. Okay. And La Nina, they predicted a flood year. Okay. But they were wrong. It turned out to be below normal. Okay, so one has to be careful. These extreme events are difficult to predict even today, especially seasonal forecast. So although it came out right that year, the next year they were wrong. And then we have a series of close to normal events. This was below normal 2018, and all because of September year. And then we had a remarkable year 2019, where the September was almost double that of 2018, and you got a really large flood year, and that almost repeated next year due to August. So what I'm trying to point out is that few years having extreme conditions cause effect on the seasonal mean rainfall, and last year was just below normal. Okay. So this was the story. So this year we have to see how things will proceed. Now you look at the onset of monsoon. As per IMD, the monsoon has reached this point. They have declared onset of Kerala on 29th May, and I don't quite agree with that. We'll see what happens there. And it's supposed to lie here, but you'll see next few days it will become stronger. But over the next 2 weeks, it doesn't look like the monsoon is going to proceed further. So that's one of the things we have to discuss. Of course, this year is a La Nina year because the La Nina, which started last monsoon, continued on as a La Nina till today, and all the forecasts indicate that it will continue to be La Nina, maybe become neutral. So, with this kind of input, I would think this year will be above normal. Okay, but I don't think IMD thinks that. Let's see. So, this is the forecast by RI for the how the La Nina will proceed. Right now, for the 70% chances that it is La Nina, and then it declines, but not much. So, as per the forecast given by IRI, at the end of the monsoon,
the rate goes fast.
right.
So, don't you think that would have an impact in terms of the change that might be happening?
Yeah, I mean the spread of this. Yeah, I think that may happen. I'll come to it because Arindam has a theory about the change from one to the other. Yeah, you're talking about this line, right? Forecast probability.
The bars, the red bars.
Oh, the red bar. Okay. Yeah. What about that?
There, you see, JJ is almost not there.
Yeah.
But the J is popping up and.
But very little, right? 5%. So.
But the trend.
Trend, yeah. Trend is very so small. So I wish they would put an error bar. I want an error bar in anything. There's no error bar in the probability. I would like to see that. How good is that forecast? So there's one more. You can look at that also. This is the other way of showing it, Bloom, and you can see both statistical and dynamical are showing La Nina all the way up to December. Okay, both of them. Because there are few cases, few models will show positive El Nino, but most of them are right around here. Okay. Now we come to the paper by Arindam, who wrote a paper, I think it's 2017, I remember the year that, in which he looked at the transition from La Nina to La Nina, La Nina to neutral, and La Nina to El Nino. Okay, there are three possibilities, and he looked at all years between 1871 and 2014. And if this year La Nina continues, then the chances of it being normal, above normal is very, very high. No chance of a drought. Okay. So how would I go on by that? That's what my gut feeling would be. This is not a model study, data, nothing else. But suppose it was not a La Nina in by August, but it becomes neutral, that goes below 0.5, then there is a small chance of a drought. So this is what I think is very high indeed. The small chance of a drought is there. 9 out of 27, that is, sorry, not small, 30%. Okay, that's quite a lot. And if it becomes El Nino, you're dead because everything is almost drought. So the transition from La Nina to El Nino is the scenario which is you don't need any model, you don't need anything. All the data shows that it will be a drought. Okay, so that is not going to happen this year. That is the. But when I say the right point, that 5%, 10%, it goes up. Yeah, there's a probability. And the same thing is showing through bar chart. I find it a little more confusing, but the same data is here. You can look at it in more detail. So the problem you look at it. What is the condition in this year and the condition in winter is in these color boxes. Okay, so we look at the paper and try to understand what he's trying to show there. Now, what condition as of end of May? End of May, Pacific looking very interesting. There's a large warming, about 30 now. Okay? Pretty large, 1.5 degrees. And of course, there's a strong La Nina and very broad also in the Pacific, and there is another warming right below it, and of course, Indian Ocean is much warmer than normal. Okay. Now, this is what complicates the issue here. It is just not the La Nina. You have to worry about this thing also. And again, both Sulochana as well as Arindam have written about it, but what role this warming plays. What we call equatorial Pacific, what role it plays on the Indian monsoon as compared to the equatorial Pacific. Okay. And of course, IOD can always cause further complications a little later. But IOD's problem is what happens here depends on what happens here. It's so close to the monsoon zone that IOD may develop rapidly one way or the other depending on what happens to the monsoon.
So that central part of the Indian Ocean, is to the north and south, that appears to be cool and warmer because usually that warm region is more or less uniform all the way up to the.
You are this one or this one?
Yeah, the one is on near the equator.
Okay, yeah, very close to normal, yeah. Yeah. And what is the error bar here in this measurement? I don't know. How many actual data we have here? The actual measurements we have in the Indian Ocean equator?
We have these.
How many we have?
Yeah, we have a number of those.
Huh?
There are about 4 of them.
Okay. Yeah. So this is the 0.5 range slope. But anyway, my view is that is going to react to the monsoon, so we don't know how it's going to work, right? We have no. Yeah, but the interesting part about this thing is that this is a thing which is of real concern. Why? Because it is an indication of a PDO, Pacific Decadal Oscillation. Okay. And the problem with PDO, I never liked it because it is very similar to El Nino phenomenon, except that it covers the larger spatial domain. Okay. So this is the end of this video. I don't know, I can't differentiate much. Okay, I know that you can. Only thing I can say is, in the case of ENSO, the warming along the equator is much stronger than the cooling of the equator. In the case of PDO, that is stronger than this. That's all the difference I can see. Okay? But of course, there's another important difference in the temporal scale, the periodicity. But even there, things are not clean. This is another picture for PDO warm phase, and this we are in cold phase now. So we saw this warm thing around Japan and cold thing around the equator. So we are in this phase, and this phase has been there for a long time. Okay, so some of the unusual extreme events we saw 31, 2019, 22 may be connected to the negative phase of the PDO. Now, so the close of the last, yeah.
If you go back to previously, if you look at the video phase, we had a series of droughts also in the later part of the first 10 years.
This part you're talking about.
Yeah.
2010.
So
Yeah.
But then video was unfavorable.
No, video was positive at that time. You got about this phase or this phase?
I'm talking of close to, I think there was 2009, there was a major drought.
Yeah, 2009 drought, yeah. You're right, 2009 will come here. Yeah, I can tell you, whatever papers you see now, on the combined effect of video and so the clarity is not there. How they work together, what's against. So I just mentioned because the pattern looks similar, but I'm not clear about how those two work together. But I'll show what arrange them, which I think is very promising. Okay. But Arina's work is only for June, July. He doesn't do JJS. And I wish he was here. He could explain better because he looked at JJS, he didn't get a good result. But I think it's very promising direction because the early phase and late phase monsoon behave differently. Okay. And I think what he is doing is very interesting. I'll show you that work. Yeah, so as a close up of video, you can see it started around 2019, later part, when we had the news, and then it has consistently been covered up to today. Okay. Yeah, now this is the part that bothers me. If you look at the spectra of video and ENSO, there is an overlap in the ENSO period. So that's why I wish it was a clean signal. Video was 20 years and this was 4 years. I'm not going to do nice analysis, linear analysis. But this is mess. So video has mostly long decade number scale, also a 4 to 5 year scale. So I don't know how people separate out such complicated overlapping phenomena. Okay. Now, if you look at the correlation between video signal and the NINO 3.4, which is what we normally use with Indian monsoon rainfall, they look very similar. Again, I have a problem. We are almost identical for all purposes. After the monsoon, they have the highest correlation, which means really it has no value predicting. Because we want a prediction here it is 0. 6 months go, 5 months, and slowly it develops. And then the monsoon time really goes. So to me, this is a clear indication that both video and ENSO are reacting to what's happening during our monsoon. Okay. Now, the other thing about video is interesting, which many people didn't realize. I remember I've been giving talks on climate change over the past 30 years now, and 35 years. So I remember a lot of people asked me questions about why the temperature declined during the 50s. As a matter of fact, I'm going to tell you when I was in school, the temperature of the world was declining. There are reports in newspaper about the next 80. Okay. A lot of cold events occurred in Russia. There was a big agricultural drought in Russia because of cold wave, and in Canada. So lots of news about ice age because that 10-year period, and that coincides with video training time. Okay. That's very interesting because, as a matter of fact, even today it's not completely resolved. One theory is that this decline in the global temperature was due to air pollution in the European American region because they put out a lot of sulfate oxides. Okay. That is one theory. If people are running models, it looks impressive. But I see this as more impressive, this connection. But here you can see we have had a decline, negative video trend, but our CO2 thing is dominating so much, you don't see much signal here. But if any of you followed the controversy on global warming, there was a temporary phase when the global index didn't change much compared to this phase. It's called a hiatus in the literature. So when that happened, all these guys have been funded by the fossil fuel lobby of coal, oil, and gas. They said, oh, no need to worry about global warming. World temperature has stabilized. It didn't subside, it went back up quite rapidly. So this is also affecting that. That's one thing to keep in mind. Okay, now let's look at how good is broadcast of IMD, both statistical and dynamical, over the last 10 years. Okay? And the news is not very good. You start with 2011. Remember that red is statistical, green is dynamical, blue is observation. Now, I can say 2011, I would say dynamical is better than statistical. 2012, you cannot say that statistical, dynamical is not right sign. Statistical, I would say, as the right sign, but no matter. Then you come to 2013, dynamical is right, statistical is wrong. 2014, I would say both got the sign right, but magnitude wrong. 2015 was a great success. That is, we have IMD made a dot prediction because both models gave the same sign, they were confident and they were right. Then you come to 2016, the La Nina, both of them got it wrong. Okay. Observation was below down. And then I don't have prediction for this. I think I remember something happened, right? You'll remember it. Dynamic model had some trouble, and Surya said that prediction is also not there. Yeah. So that year there was some problem with the way the model was run. So there's only statistical and it agrees with observation. Then we come to 2018, the severe drought, that's the one maybe we're talking about. And signed right, but magnitude is wrong. And you come to 2019, which was a very unusual year. Both of them got it wrong. The September rainfall was so high, nobody got it right. Nobody knew what. Then you come to 2020, I would say, again, dynamic is superior statistical. And 2021, I would say both are wrong. So that is story. So it's a very mixed bag, okay? So the key message is seasonal forecasting is a nightmare. We don't understand either the statistical model well enough to be able to put with great confidence. Now, this is not surprising. The complex system, we have not figured out all the things is playing a role. You will see all that when I explain Arindam's model. So the point is that we are definitely improving compared to the previous 20 years, but still we have a long way to go. That's a tough problem, not an easy problem. Now, just to give an example, 2020, because around last week I made, yesterday or today, they made prediction of more detail. And in 2020, they were wrong in most of them except for Northeast India. So, all India is one, all India is only our interest. We want regional, regionally predictions are not very good. Last year was better. Okay, now let's look at the forecast that was issued by IMD 2 times on 14th April and 31st May. Okay. On 14th April, said 99%, which I'm not happy with, but then they increased it by 4%. That means they recognize the role of La Nina and negative video, I think. Skymet usually says normal, so it says normal. Now, the point is that these will look quite close. So you can say that both are similar. But look at the distribution, that's very important. The distribution, this is the climatological, one third, what's called percile. But if you look at the forecast probability, this was the forecast 14th April, 31st May, and Skymet. Okay? Now you can see that IMD tends to predict slight chance for deficient while Skymet just rolls it up totally. Then you come to the next level, 90 to 96. This is 26, 14, 25. So interestingly, IMD which said 26 and this 25, they have actually brought it down. Because now they think La Nina is more important problem. Come to normal, very interesting, this is 40, 36, 65. So our friend in Skymet are predicting a much higher probability on normal than IMD. Then you come to above normal. Again, I would say on April 14th, IMD was not very far from Skymet, but now they are much higher above normal. And of course, this is most interesting. They jumped from 5 to 19. I would like to know what is the explanation in the forecast given yesterday, but I'm really curious that this is jumped up. But I suspect that if La Nina persists and negative PDO is not going to change overnight, I think chances of above normal is higher. Okay, these are the more details. I will not. We'll discuss at the end of this discussion in September how good these forecasts are. We just put it there for your interest. And same thing, Skymet. Skymet says June is above normal. They'll be definitely wrong. I can guarantee. You see why? Monsoon is not progressing. It is stuck somewhere in Kerala, and even that I might doubt. So I don't think June will be above normal unless something unusual happens. Okay. This are all not very interesting predictions. Now this is the from CFS website in MSEP, not Indian. This one. They are predicting for June based on Mainish condition above normal in North India, below normal South India. Now that is partly maybe true because South India, because of the delay in the monsoon progression, maybe it will not be above normal. And if the thing really progresses for the next 2 weeks and goes here, maybe it will be above normal. So just read over this. So at the end of June, we'll look at it again and see how right they were.
This map is missing the
Huh?
this map is missing the main regions of high rainfall, right?
Yeah.
That red patch is mostly in the rain shadow region.
Yeah, you're right. So Kerala part, I don't know which one, Ravi may know better. Is the NSAP is running the water resolution?
T1.
Huh?
They still are T1.
Okay. So you're right. I don't know what is our Kerala. I don't know what comes in Kerala. That's not visible there.
Yeah, even in the Kerala.
Yeah. Complete. Yeah, but I'll be careful. They don't make ocean prediction in this. This is the NSAP. NSAP somehow blocks out the ocean body. I don't know. Yeah, this is the IMD prediction, okay, for June, based on mainland condition. And here, again, they are showing South India is below normal and Maharashtra and Andhra above normal, again, above normal here. But I would say this is a probability, this is not actual numbers. So they cannot be looked at same way. And this is the full season. That is below normal, normal, above normal. Again, their claim is it will be above normal except for Kerala. It will be above normal all the way across here, except for part of the northeast and maybe Odisha and West Bengal. Okay. So keep that in mind, and at the end of the season, we'll discuss that. Now, this is the forecast from the South Asian, or what's full name? Remember South Asian?
South Asian.
Something. Yeah, this is the South Korea, right? This is South Korea or the Federation?
India and
yeah, they issue a forecast also around this time. So that is also not very different. I would argue they also
are a consensus forecast.
Yeah.
They kind of look at all of them.
Yeah. They give a committee decision. Okay. Now that finishes the season forecast. I have nothing to say. We'll wait for the season to end and we'll have a discussion on September 30th or so. Who came out right? Now we come to onset. Now this year's onset was problematic. It was not straightforward. And the success of IMD or onset using statistical formula is very good. Okay. You see the record here. I would say most of the time they are quite close to plus or minus 4 days, which is the error in the method. So I'm quite impressed by that technique. But this year didn't do that well. They claim to do well because they declared onset on 29th May. Okay. And so this is the error bar. But I'll show you the result. They don't look promising. Okay. So this you have to look at and we'll discuss that. Or maybe I'll ask Rajiv to tell something more about it.
Now, yeah. Extended range forecast. Extended range forecast. 2 weeks. Still looks quite weak. It doesn't look like it will be very active.
Yeah.
Only I think after 9th of June.
Yeah, I showed that. I'm going to show that because that's my whole point. Not only the onset really rigorously, it is not moving. Yeah. Now, this is the onset forecast that Arindam makes. Unfortunately, Arindam doesn't make public announcement. They only lots of people in IMD and cross-meet tells me. I wish you would do that. It should get into that. So this is a paper published a couple of years ago, 5 years ago. Please read it. Very interesting paper because this is more physics-based. This is not just statistical. There's some physics about how the low pressure develops and how it affects the monsoon and how the circulation patterns change. So he told me before he had to go home that he thinks onset will around 8 June. That's what he told me 2 weeks back. Okay. He didn't believe the 27th May forecast of IMD. So he said, no, this year is unusual because of negative PDO. So his model has 2 different ways of predicting positive negative PDO. Okay. That's an interesting thing. And so when he comes back, I'll ask him to make some comments on that. Now, you must remember that our onset does not come first. Other onsets are going on here over East Asia before it comes here. So to me, one of the problems which is not fully addressed in the statistical method that IMD developed is the impact of onset in nearby monsoons over Myanmar and on the onset of this. Because they have to be connected, they're so close. Whatever happens, they will have an effect here. But that is not adequately discussed. They are given only on the parameters right here, mostly. Yeah, so you look at the climatological onset phenomena over Kerala, Trivandrum, it's very impressive. I like the picture image because it goes from 4 millimeters per day to 20 in one day. But that's the mean value, that is the mean of all onsets. Okay? Nice for textbooks. But real world is not like a textbook. Real world is always a bit messy. The other interesting thing I like about the picture is the relative humidity. That is the key. The humidity has to be sufficiently high at high levels before onset can occur. So this is what is the key. The 80% humidity at about 720 millibar is the key to the onset. Oh, no. Yeah, no, this should not, I'm sorry, this should not accompany. Okay, now let me give a few examples of onset over Kerala, which are sometimes called bogus onset or unusual onset. This is 1991. Starts well and goes on raining for another week or so. This is what I would call is a normal onset. This is another year, slightly late onset, then it sort of declines and then picks up a little later. But I want to look at 1972, which was a very bad year for India, one of the biggest droughts of all time. The onset started on 15th May. Okay, and then the whole till 15th June, the Kerala did not get much rain. Okay, so this is the kind of thing which could occur. You may have an early onset, but then the monsoon does not develop further. So to me, this calls for. So I can understand that before the advent of satellite, I can understand the I admire them because with very limited data, they did wonders. Okay? At that time, no satellite, only data in Kerala. It's a brilliant piece of work. But today we have satellite data for 60 years. I would rather have an onset defined by satellite data because it has a large synoptic view. Okay, we have all the data on the ground mostly is over land, over Arabian Sea, except for SAT data along the equator. We don't have too much data over Arabian Sea. So to me, people should look at defining onset purely from satellite basis. Okay, this is the onset definition used by IMD. They look at 14 stations which under Krishna identified, and if 60% get more than 2.5, that's what happened on 29th May, Zoo. And then they look at the westerly, it's very important, it has to go deep enough. And they choose up to 600 millibar, they choose a box lies to the west of Kerala. And finally, it overlaps. Now, this is, they have reduced that because the satellite data is there. Okay. So it looks quite good. It looks at rain over Kerala, it looks at how the wind has developed, it also looks at cloudiness. And what I may declare that all the three were satisfied on 29th May. Fine, I do not argue on that. Okay, now I looked at the website of the Kerala Department website, and it is true. If you look at, they only have unfortunately the seasonal means pre-monsoon rainfall. All the stations in Kerala, pre-monsoon, they've got above normal rain, all of them. Okay. But that's not monsoon. A lot of rain occurred in May, all of you know. Both Karnataka and Kerala got lots of rainfall in May. That's a pre-monsoon phenomenon. Now let's look at the forecast for the next week. I can see this is what Ravi was mentioning, and you can see that this thing, which is through which onset are declared, is not really occurring in Western Arabian Sea. Okay? There's a lot of area of below normal rainfall as per the forecast. Okay. And it is getting worse. This is this week. Okay? Look at next week. Look at this. What surprises me is it says rain over North Karnataka and maybe even Maharashtra, but not over Kerala. And here it has already gone over to Northeast and there nothing much here. So you compare this to this. This is NCMW, this is IMD, and when you travel this, what surprises me is the two arms of MOAs can't agree on a color bar. They use two different color bars. It worries me. I've told them, but nothing is happening. So you have to stretch your mind a little bit. This was at 20. So I would say more or less this and this are similar if you accept the color bar. They all agree that maybe by 15 June, there's rainfall occurred here. But still over Kerala, there is no indication it's going to rain till 23rd. Of course, we don't have to believe this is too far away. We know the Actually, the forecast is good only here and here. This one is not good. So I would say maybe beyond 9th June, chances of rain over Kerala is there. Okay, so this is the forecast MMB multi-model ensemble. This also to me, in the week of the onset date, you can see that there is a clear onset over the Arabian Sea, but fairly touching Kerala. So to me, this is a problematic situation. And so let's see what the other data shows. Now, this is the Rajiv Pai's paper on the onset. They do an average of the OLR on the onset date. They look at the data onset and plot the OLR, and you can see that the low OLR is hugging the coast of Kerala. That's what is the canonical thing which I like. It was not that way this year. This year was different. But how was it? This was windy, which I like. Windy website is very user friendly. This is actual rainfall in millimeters per day. And you can see on 29th May, when I declared onset, there is no rain in Kerala. Hardly. So the real rain occurred right to the west of Kerala, very large rain, goes up to 100 millimeters per day. So I would say onset occurred over Arabian Sea, East Arabian Sea, but not over Kerala. That's what the satellite shows. Now this is 29th May. It got even higher rainfall here, right all around here. It is not touching Kerala. Kerala is very low rainfall region. Okay. Sorry, this is OLR, right? Yeah, this is OLR. So I want to make sure that because rainfall that is derived from satellite data has its problem. We all know that. Those of you who have taken the course of judgment. So I thought OLR is better. This is OLR. So deep clouds are there to the west of Kerala, south of Kerala, or Kerala, OLR is 250 watt meters per which is not a deep cloud at all. Okay. And one more picture, 28 May, same. It's hanging around well away from Kerala. Now let's look at the winds. According to Rajiv Pai's paper, the strong winds build up on the onset day and peak value is around 10 knots or so, 10, 12 knots. This is what it should be on an onset day. Let's see what is that this year. This year on 28th May, there was a high wind speed right along the coast of Africa, not India, and the thing went down and the more intense wind over Bay of Bengal going into Myanmar. Okay? So to me, this had influence on this amount. This is 28, one day before the onset declaration. Let's look at, oh, I don't know. But let me tell you what happened before that. All of you know that, those who are in Bangalore, that we had a very unusually high rainfall in the middle of May related to cyclone and so on. And that came all the way from West Pacific, all the way across. And then we had this period. This is not indication of onset. Okay, this is all very, this is whatever content which I favored. So whatever content is below normal here, was above normal in the middle of May due to cyclones and different, and then it switched over to this is what is causing problems, which is on the date of the onset also very low, whatever compared to normal. Okay, now what is the forecast by IMD for the next 3 weeks? All India, South India, I just said South India, and you can see clearly up to 9 June, South India will not get for the latest. There are two conditions: 18th May and 25th May. The next one will come today. Both say that well below normal, 20% below normal, and only after 10 June does the indication will jump. Okay. All they indicate that although there is no answer, situation will be poor till about 10 June. And this is the forecast from NSF-CFS based on 28 main conditions. Again, look at the values. Absolutely, whole of India is negative value of rain millimeter per day right here. That is week 1. Week 1 means 29th to 4th June. Let's look at week 2. It is 5th June to 12th June. Again, no chance. Okay. So based on what we have looked at in this discussion for the last 8 years, we know the first 2 weeks forecasts are quite good, so the chances of monsoon reviving before 12th June is very low. And there's week 3, okay. Hope. Week 3 has come, but hope is not for us, but for North India or Central India. So that's what interests me. As a matter of fact, I asked even maybe somebody will know, has there ever been a year where the onset over Mumbai occurred earlier than onset over Kerala? Rajan has been no, but I vaguely remember.
It happened.
Huh?
I mean, it came close in the Arabian Sea.
Yeah.
I don't know whether it, actually there was an onset in Kerala, but it jumped northward and went to Mumbai. It was the last decade itself.
Yeah, I don't know somewhere around it happened. So I tried to look up all the onset dates of Mumbai and Kerala. Are there any time in Mumbai? So it doesn't know some, but it was looking at it.
So then onsets quite often are.
Yeah, I know. Not always. But I think it's interesting that the rainfall, according to CFR, in week 3, which is not that reliable forecast, is going to have a nice IT season right across from Bay Bengal to this one, completely going past South India. I remember, I must tell you, but recently I realized, see, we all talk about IT season is a nice, idealized world. Real world is not ideal. It works over ocean beautifully. You can look up windy website anytime in winter. There's a beautiful east-west orientation. As soon as you come over India, the problem is actually Western Ghats. Because Western Ghats, you will never see, if anybody see, please show me, you'll never see a cloud band across like that. They will never see. Because of the leeward side, the flow is going down. So you cannot have an IT season going across India in the South India. North India is okay. Once you cross the Western Ghats, you get a nice horizontal, but here you won't get. That's an interesting feature. You must keep in mind that India is a very difficult country. It has Western Ghats, it has Himalayas. Both these mess with our ability to forecast. Okay, so this is the All India forecast, which I'll keep showing during the course of the discussion. Again, all are below normal till 9 June. Okay, all below normal. And now I come to the June forecast. Now, Sulochana and Francis have a very interesting paper. They discussed El Nino, but I'm sure the same logic over the La Nina reverse. And they argued, they wanted to understand 2015, when in spite of the El Nino, the rainfall in June was above normal. So they want to understand why. And ultimately, in the paper, we read it, it is in current terms, you can easily get it. It is due to a warming in the Western Pacific Ocean around 20 to 30 knots. Okay. So this year the warming is there, but there's a La Nina. So I don't know whether they'll cancel out or not. I'm not from her paper. She uses the Intel index, which is opposite of 3.4. You remember that. So this year, according to her definition, it will be around 1. So I would say very difficult. It will be equal probability of the above normal in this case. Now I'll come to Arindam's paper, which I don't know how many of you have seen it because published in Mosum. Many of you may not see it. Okay? But I strongly recommend. Mosum is not online. I suggest a lot of papers in this paper are there. and that this one, Arindam has done something very unusual. Because most of the focus has been IoT and 3.4. He focused on Marcus, okay, which seems to be very active in the last decade. And he defined as Indo-Pacific SST index. Okay? The only thing I don't like is that index is based on SST, but units are millimeters per day. I didn't like it, I told him, but he likes it because he wants to use the same notation for the rainfall anomaly and the index, which I'm not ordered over SST. Okay. So remember that in this index, these constants are millimeters per day per degree centigrade. That's what he's using. But what is interesting about this model is these two C values are quite high, and this represents one region similar to Sulochana and Francis. Other one is he has identified a little bit to the north and to the east. And if you put rough numbers there, I didn't know exact numbers, put rough numbers there in the month of May, this will add up to about 1 millimeter per day extra. So according to Arindam's prediction, based on SSC in the month of May, for example, the rainfall in June will be above normal. July, not June. Notice this. He doesn't use this, June, July combines it. So the possibility exists that June will be below normal, but July is above normal. Combine it, maybe it will. Let's see. So this is the interesting forecast. I tell you why I like this forecast. This is the only time I've seen, it's not a forecast, I'm sorry, association. Only time the association which has 0.91 correlation, which I've never seen in anything I've seen. You look at it, ENSO is 0.4, 0.5. So to me, it's remarkable. And I think it should be studied further, because what is showing clearly is that most people only focus on these two. Sulochana had a paper and she combined these two. By adding these two, he is increasing the correlation by a huge amount, associatively, and he is able to get almost all the years on the line, which I think is quite remarkable. So this is the acid test for Arindam's model. So in the course of this, we will see the right or wrong. Okay, now we will look at the role of Mann-Huijsen oscillation, because it seems to have done something this year. Okay? The delayed onset and all this next 15 days is due to MGO. Now, I think it's worth remembering this year, because MGO, which those who knew it, is this system of tropical rainfall going eastward along the equator, which has an effect on the Indian monsoon. And you can see that the anomaly is positive here, it is negative here. This is what happened this year. This is where the MGO was around the onset time, and still hanging there. And as long as it is there, India will have a problem. Now, the reason why I want to mention this is, this was identified more than 50 years ago. And there are two papers published. 71 was the first paper, but that only talked about the period of the oscillation. In 72, there was a remarkable picture drawn by Madden and Julian. And I want to tell you again, please remember, all of you young people will never understand the fact that Madden and Julian had no data of satellite. Only data was a few stations along the equator. Based on that, based on the imagination, like Sir Gilbert Walker, they constructed road map over the entire globe. I mean, that is remarkable. So the 50th year we will all celebrate that this paper, which is the most famous paper in quantum science, that they were able to draw this picture based just on a few stations along the equator and entire circulation pattern, everything they identified. And to me, that shows the power of Madden's statistician, the power of statistics to unravel the result. Okay. Now, there is a paper published a few years ago on the impact of MGO on the summer monsoon over India. So, if it is strong, that is normalized 1 above 1, then it has effect over onset monsoon, provided it is in the right location. So, phase 2 is when it is somewhere close to the east coast of Africa, and this is where this year, not quite 8 years, I'll show you, we are in a different phase. Okay. Yeah, again, this is what is there from the IMD website. You can see that this is OLR. So the problem is right now, entire area is negative OLR. Okay. Until this thing comes here, around 13 June, you will not get further. So this is the strength of the LGO. This is the OLR pattern. And you can see all that going on. So this you can look up at the IMD website. It's quite, although navigating is not easy, but you can look it up. So all the clearly indicate that for next 10 days, the monsoon is not going to progress too well because of this phenomenon. Now, there is one more way to look at it, which we will be doing during the course discussion. This is looking at the velocity potential at 200 millibar. Okay, and what it shows is that on 25th May, okay, India is here. Things are okay. Over in the upper troposphere of India, air was diverging, which is favorable for rainfall, and the air was converging over Atlantic. Okay, within 3 days, that system moved over to the right, and we were stuck here. 28th May, next day onset was declared, but I think conditions were too unfavorable for Indian monsoon because there was convergence in the upper troposphere, which cannot really create very strong rainfall. So this is the indication that what happened during the onset phase. Okay, so I want to end with another interesting story. cyclone, or the major cyclone, remember, forget the name. What is the name of the cyclone? I only forget names. Anyway, this cyclone was the most interesting cyclone I've seen because all of you remember that the major success of MOAs and IMD over the last 10 years is the fact that the cyclone forecast is very accurate. It's so accurate that they were able to say many lives in Orissa and other places. So it has a great success of data assimilation, model, and communication to public, all that wonderful. This year they failed totally. Now it is very rare, doesn't happen often, and it is worth understanding why. I think people have to now do a lot of post-mortem and find out why they got the direction wrong. Not they, everyone. So I would always like to remember that if all the people are wrong, that's why you should jump in. That's why you have a good chance of doing something new. Okay? If all the models are wrong, that means there is something fundamentally wrong in the whole model. Not little adjusting a scheme here or adjusting a no. Something is fundamentally wrong. So that's what I want you to look at. Okay, now this was the record of IMD for the last this 10-year period. Remarkable. Landmark is just 56 kilometers from 100 kilometers and a half. So this is major achievement and full credit to them. But this year they failed. Now what did they predict? They predicted on 10th May that the cyclone will veer towards the east and go all the way to this. Now, if any of you study cyclone broadcasting, it is not, it's an art, it's not a science. Why is that? Because the major argument given for the cyclone where it's moving is called the steering wind. Okay? Steering wind is like you throw a flower on a river and the flower is carried by the wind, right? So you think of cyclone as a vortex embedded in the flow. It's a nice analogy, but only two problems occur as far as we are concerned. One is, unfortunately, all of you know, there's a strong vertical shear. So in the monsoon season, even pre-monsoon, winds are blowing one way and the upper wind blowing another way. Okay, so that's the first complication. So when you say steering wind, at what level? If you choose a level in the low troposphere, you get one direction. You choose upper other direction. Most of the time, they choose the upper troposphere. They believe that's what controls. So they go average between 500 to 200. But that's purely empirical. There is no real full understanding. And the main reason why they don't understand is you cannot imagine this vortex being taken in a stream because the vortex is so strong, it affects the circulation itself. So it's not a simple system where you throw vortex in. That kind of what we have done in fluid mechanics and in mechanical engineering, those are simple cases where you have a weak vortex and a strong flow. Yes, it will flow with the flow. But if you have a strong vortex, it affects the local circulation. So let's see what happened with other models. All the other models, there are many others you can see that, all of them said same thing. So IMD is not at fault, all the models are at fault. And what happened, as all of you know, is that the thing veered to the left and a huge region of Andhra Pradesh and even Karnataka, where anyone went to Bangalore after this landfall, and they are not able to predict well in advance. And luckily, it was not a very severe cyclone. It didn't cause any death and so on. Maybe a few, but it didn't, if it had been a major cyclone and it had gone in the wrong direction, it would have been a serious issue. At the same time, I want to first tell you that the models are good. Just before that, there was a twin depression on either side of the equator. Beautiful thing which happened around the 8th May, and the model correction predicted that. I was really impressed that the strong westerly along the equator became with two vortices, which is a classical textbook kind of explanation. Exactly, they got it right. So there are lots of things good in the model, but there are still some things you have to worry about. And this is the initial phase where this is what, yeah, this is 6th May. They were able to correctly get the onset itself when the depressions were forming, the twin on either side, they become, so both are correctly predicted by the model. So models are able to even see the cyclone initiation, which is very tough. Remember that in the background field, suddenly a vortex forms. That they're able to get. And this is another thing I like to show in windy, simultaneous occurrence of a low, which is a heat low, and it is a depression, the same on the same day, which is a very nice example of what's happening in the pre-monsoon season. Okay. Okay, so I'm going to end saying monsoon 2022 is going to be very interesting. My guess is that the whole number we'll see it at the end of the season. And so we'll meet you next week and we'll continue this. Okay. Thank you. So, any questions? Somebody else? Let the students.
Yes, I have one question. One of the reasons is that the cyclone came very close to the coast and there was not enough heat content in the ocean.
Yeah.
There was not enough heat content in the ocean and hence it could not kind of go faster or kind of.
Yeah, why is the water not captured? That's my question. Yeah, why is that? I tell you, I understand when the sweat goes close to the land, it's asymmetric coordination, very tough outside the buffer. It's not an easy problem, it's a very tough problem. But that also happened in Orissa last time, they managed it. So, what is so unique about this cyclone that they have to be still have over Orissa and over Kolkata? Many cyclones, everything in one time, right?
No, but this also happened about 10 years back. In a very similar.
Yeah, but
kind of fizzled out in the middle.
Yeah, but very tell me over 10 years, how many cyclones you bring? Maybe 50 or 70. Yeah, all of that is wrong. So to me, quite good, but it is very important from an academic point of view to understand those two, right? Yeah, that's the whole point I'm going to tell students, that you look for the outlier, you look for the crazy case to figure out what could be wrong. Because when all models go wrong, I think it's very interesting phenomenon. That means something is wrong in all the models, which I think is very surprising. Because you put all of them put so much effort, there are 10, 20 groups in the world who have spent all their time doing remote broadcasting. All of them go wrong. So I talked to Tata, he promised that he will do all that and maybe one of these days, last week he will turn around. Yeah, anybody else? Yeah.
How can you understand the role of visiting Northwest?
I can't hear you.
How can you understand the role of Northwest when tropical vegetation is so strong?
If you want to understand the role of Northwest and Western, read a paper by Surasama and Sajid, the Momo paper, where it shows the role of what is being done. How to do it, very well, what is called circumglobal preparation bonds. That paper. Read that paper, interesting. And so, Arindam has no theory. Arindam only has this one, but Sajid is Surasama, actually look at it based on Zimmerman's work in our very interesting piece of work. How a company having 20 knots is related to intrusion of the rock region. Very important. Yeah, maybe. Okay, anybody, is that all? Okay, so thank you.